Okay, so in this lesson we kind of combine lessons 6.4 and 6.5 because they cover the same properties and the same shapes. So in this lesson we're going to talk about properties of rhombuses, rectangles, and squares. So our objective is to define and classify special types of parallelograms and to use the properties of diagonals of rhombuses and rectangles. So we've got to be solid in the properties of parallelograms. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, diagonals bisect each other. That's what we just got quizzed on. We're going to extend that to more specific types of parallelograms. The first one is a rhombus. And the most basic definition of a rhombus is a parallelogram with four congruent sides. Okay, four congruent sides. A rectangle is a parallelogram with four right angles. And a square is kind of like a combination of a rectangle and a rhombus. It has both of those properties. It has four congruent sides, and it has four right angles. So this Venn diagram below here illustrates important relationships among parallelograms, rhombuses, rectangles, and squares. So we can see that a square is a rhombus because it is a parallelogram with four congruent sides. Because it has four right angles, a square is also a rectangle. So all squares are rectangles and all squares are rhombuses, but not all rectangles are squares and not all rhombuses are squares, because not all rhombuses have four congruent angles or four right angles. Not all rectangles have four congruent sides. So in example 1, we're just going to be classifying special parallelograms. So we're going to ask, is it a rhombus, rectangle, or square? So in part A, this shape, we can classify it as a square. Okay? Part A, this is a square. And the reason it is a square is because each of these is a parallelogram. So that means that opposite sides are congruent, which means all four sides are congruent, which makes this a rhombus. Okay? And the fact that it's also a rectangle, because in a parallelogram, opposite angles are congruent, consecutive angles are supplementary. So it's a square because it has four congruent sides and it has four right angles. So it is a rhombus and a rectangle at the same time. That makes it a square. In part B, this shape is just a rhombus. Okay? It's just a rhombus. It has four congruent sides, but no right angles. So it's just a rhombus. In part C, this shape is just a rectangle. It has four right angles, but not all sides are congruent. Okay, not all sides are congruent. So that's how we classify shapes. We first look at the angles and the sides and then decide, are all four sides congruent? Are all four angles right? So those are the most basic features of rhombuses, rectangles, and squares. We're going to go a little bit more in depth, and we're going to talk about the diagonals and the opposite angles of just a rhombus for now. So a parallelogram is a rhombus if and only if, so it's a rhombus if and only if its diagonals are perpendicular. That means its diagonals create right angles. Okay? Diagonals are perpendicular for rhombuses only. The opposite angles of a rhombus. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles, which means the diagonals bisect each angle. So in this rhombus to the right, A and C are the same measure and they're being bisected. B and D are the same measure and they're being bisected. So we're going to get some practice finding measures of angles inside of a rhombus. So we got to remember some important features of a rhombus. So in this, AED, the angle AED, the measure of it is 90 degrees because AED is this angle. Okay. So diagonals are perpendicular in a rhombus. So AED would be 90 degrees. ADE if we look at this bottom part of this rhombus as a triangle, the way I'd find the measure of ADE is understanding if in that triangle E is 90, A is 67, I would find ADE by taking 90 minus 67, which makes ADE 23 degrees. So kind of breaking up the rhombus into triangles really helps us narrow down what angle measures are, okay? The final one, BAE, I'm going to use a different color. I'm going to use blue. BAE is this angle right here. Since diagonals bisect the angles of a rhombus, BAE is also 67, okay? It's also 67. And then the final two measures, AE, is just remembering that a rhombus is already a parallelogram, so diagonals bisect each other, which makes AE have a measure of 5 and gives BE a measure of 12. So that's going back to a feature, a property of parallelograms to describe how the diagonals bisect each other. So talking about the diagonals of a rhombus, talking about how the diagonals of a rhombus bisect the angles and how the diagonals form a perpendicular in the middle of that rhombus.